Hey guys, welcome to Deep Dive Coding. Today we solve LeetCode problem of the day, and in this video I will explain the most optimal solutions and also the space optimal solutions. So the problem is longest balanced subarray 1. In this video I will go through this way. First explain the questions, then simulate the test case, then approach, code explanations, complexity analysis, and finally one optimized versions of the code. So without further delay, let's start the video. So question given, there is given as nums array, which is an integer array, and we have to perform some task, like we have to return the length of the longest balanced subarray. What it mean by balance? The balancing conditions is number of unique odd number and number of unique even number. This have to be the equal. That means let's consider this example, 2 5 4 3. So if you take this as the whole sub array, so even count would be, you consider even count, unique even count, that is 2 and 4, so it will be 2, and odd count would be 5 and 3, so it will be 2. So over here this whole array is balanced as the unique odd count and unique number of even count is same. Now let's simulate the test case. So if you take, you can consider, there is given as subarray length, so you can consider this much portions also. Let's, if you consider this much portions, so it will be like 2 5, one odd count, even count would be 1, and odd count also 1. So it is also a balanced, but we have to return the longest, that means as maximum as possible. So we just look into that thing. So if we consider whole array as a subarray, so is it valid the conditions? Let's check it. Even count would be 2, which is 2 and 4, and odd count would be also 2, that is 5 and 3. So yeah, if we take whole array, then it is also balanced, so we answer is over 4. Now come into the second example. Second example is also, let's take the whole array, just randomly taken. Okay, so if you count the odd count, unique odd count, so it will be like 3 5, that will be 2, so it will be like 3 and 5. And if you check the even count, that will be like 2 and 4, so it will be 2, over here 2 and 4. You consider this 2 is repeating, like 2 and 2, 1 2, because we just need to unique number of counts. But when we calculate the length, we can take whole array as the length, so answer is 5. Now come into the third example. So third example, even count. So if you take the whole array, so even count would be this 2, so it will be like 1 for 2, and odd count would be the 1 and 3, so it will be 2, 1 and 3. Is it balanced? No, it is not balanced. So we have to take minimum, so we can take this much portions, 2 3 2, these portions. Then odd count is 1, and even count is also 1, so this is the maximum balanced subarray, so answer is 3. Now I think you got the questions correctly. Now come into the approach. So basically we first of all write almost a brute force approach, like we want to know the subarray unique odd and even count. Let's say we given an array, and if we consider this is the subarray, then we want to know the unique odd count, and also want to know the unique even count. These operations, if we effectively solve it, then we can consider whether we consider these portions or not. We track via the unordered set or hash set to unique even count and odd count. Now what are the steps you can follow? first we fix the starting index. We just iterating for each array we just, let's say there are elements, so we just first fix the starting index as I, and we extend the j index from the I to n minus 1. This portion is the j traversals. For each I and j we just track two hash sets. Like for starting index of this one, we initialized odd as an hash set and even as an hash set to count the elements uniquely. And for each subarray we check the length of the two hash set, odd and even. If these two are same, that means odd count and even count, that would be also unique, is the same, then we take the length and update the maximum length. So in this way we can solve this. It's almost a brute force. There is a optimal solutions I will give in the almost end of this video. So coming to the coding explanations part, coding is also simple. We first int n equal to nums dot size and take the length to track the maximum length. Try for the brute force approach. Try all the subarray starting at index I, that means I equal to 0 to n minus 1. So each index, starting index, we just define an unordered set, or it is, you can consider as hash set. I give the explanations in C++, but Java and Python version you can get in the YouTube descriptions, and there I will attach there, and both of them are almost similar structure. Now we take the hash set or unordered sets of odd and even to store the distinct values. Now it start from the j pointer, j equal to I to n minus 1 and j plus plus, and now we have to classify current element whether it is odd or even. If nums of j modulo 2 equal to 0, that means it is divisible by 2, that means it's even, and if it is not, then it means odd. We just according to that we just insert odd or even hash set. Now for each I and j we just check the balancing conditions. If odd dot size and even dot size is equal, that means the valid length of the subarray. So we just track the length j minus I plus 1, and at last we just return the maximum length. So I think this coding part is almost clear, because it's almost a brute force approach you consider. Now come into the complexity part. So this code is running big O of n times, and this also running you consider big O of n times, and these insert functions, and over here also insert functions, these are the big O of 1 operations, and this also big O of 1 operations. But at the odd scenario it can go big O of n, but it's not in the normal cases, so you consider amortize big O of 1 time complexity. Now if you combine these two things, then total time complexity would be big O of n square time complexity. And for the space we taking two extra space, that is odd and even, so it can go, you consider big O of 2n, or you consider this is as big O of n space complexity. Okay, now I will show you the optimized versions of the code, but before going into that, please like and subscribe the channel, and also comment that this is a helpful video, that will be great for me. Now come into the optimized code version. So optimized code versions is we just reduce the space complexity. How we can reduce? Now I will explain from over here. Now similarly n equal to nums dot size, this is fine as the previous one also. Now int answers equal to 0 to track the answers that you consider as maximum length, and now a start pointer is 0 to n minus 1, and also over here end pointer start to n minus 1. These are the same as in the previous, but what we have improved in, that is space complexity. That means we taken there is a constant given that element can go at max as 10 to the power 5. That means whatever there is given a num psi, so num psi go as max as 10 to the power 5. So we defined as fixed sized array, that is 10 to the power 5 plus 1 space, to track the whether we have already seen that element or not. And what is run id, I will explain in later. Now these are the static and also inline. That means for this class these two things are already saved. For you consider that each and every object, as this is the static variable, so this static variable is accessible all the objects. So whenever this function is called, this static variable does not update. So and run id is basically to track the run each subarray id. We start from start equal to 0 to n minus 1 and we plus the run id. Why? Because we just unique id for each subarray. We do not need to update. Like if we define a global variable, this is the you consider as a global variable, but we have to clean that array. But if we define id so that we can just track whether this id is occur or not. Let's simple take an example. Let you consider this is consider as val is a variable name and this is a global id, like global variable. And you know, in your one object, let's say object 1 is increase this value from 0 to 1, and object 2, when it's called object 2, object 2 will go to from get the 1 as the input and it can increase the 2, so it will be global variable updated as 2. But if we want to initialize an array, okay, and we update some operations, like we perform some operations, let's consider this is 0 1 10 to the power 5 and 8 7 6 3, just putting a random variable. And when you next time when you like use the same array, we have to clean the array like before we use, because otherwise it will be wrong result. But we over here we do not need to update that array. Why? Because we just use a run id. You consider as consider timestamp. Let's consider run id as 0. When we process initially, then that will be the run id for 0. Whenever let's say -1 is initialized first, then when we process that variable and when run id equal to, let's consider run id equal to 0, and according to that we just update our array, and let's consider these are the things updated. Now when we process the next function, like next time, so that time run id will be the 1. We just check whether its run id is 1 or not. If it is not, that would be we have not calculated yet. That is the like importance of the run id. Now coming to this part, value is nums of end, and we just if the scene of value not equal to run id, that means whatever value store in the like where value positions that is not equal to run id, that means in these iterations we have not touched that. So we just update the run id, and if the value, that means we are in that means we are seeing this val as first time, and value modulo 2 equal to 0, that means even count is increases, otherwise odd count increases. And similarly if the even and odd count is same, that means we have to update the our answers, that is n minus start plus 1. And this will be reduce the space complexity. First of all, this scene fixed sized array is utilized by each and every function call. And another thing is run id use the, we do not need to clearing operations of scene, so we can use this run id to do that part. So you consider the time complexity is same, that is big O of n square, but the space complexity is you consider as big O of 1. Because why? Because we are using, I will write over here that key optimizations, we replace unordered set to the fixed size array to look over in big O of 1 time complexity. Another thing is run id used as the timestamp, as I already said. And another thing is we eliminate the hashing and dynamic memory allocations and clearing overhead using this time id. So it will give you the optimal approach. Thank you guys, thank you for watching. Stay tuned for more videos, and I will attach these notes in the YouTube descriptions. Thank you guys.